Okay, so we are in a statistic course and we were talking about frequencies. Now here, these are the ages, age 1, 2, 3, 4, 5, 6. What this means here, frequency, this means that students with age 1, or maybe it's little children, okay? So 5 students, 5 people with age 1. We have 3 people with age 2, 7 age 3, 5 age 2. So these are number of people or kids that we have. Now, if we want to group these kids, how we can group them? Now, let us say age group, okay? What is important in grouping is that you don't have same numbers here. For example, I cannot write 1, 3 here because 3 is included here. Kids with age 3 are here. Okay, now 1. Here. We have kids with age 1, 2, 3, 4, 5, 6, okay? And these are the frequencies. Now, here, kids with age 1, 2, I have 8 kids, okay? I have 5 kids age 1, and I have 3 kids age 2, okay? That's 8. Now here, 3 and 4, I have 7 kids age 3, and I have 5 kids age 4. So altogether, that's 12, okay? 5, 6, I have 4 kids age 5 and I have 2 kids age 6. Okay, so that's 4 plus 2 is 6. That's grouping. Let's pass to the next slide. Okay, here. This is cumulative frequency. You can see here. Now, I write 1, okay, 5, 2, 3. So these are the frequencies of these kids with these ages. Now, cumulative frequency is calculating, adding this one and the next one, okay? 5 plus 3 is 8, okay? So this means 8 until here. Until age 2, I have 8 kids. Until age 15, I have 10 plus 5, I have 15 kids, okay? Until age 3. This is 20. What it means? This means until age 4, I have 10, 5, and 5, altogether 20, okay? That's how we get cumulative frequency. Okay. In your exam, I am going to leave this column empty, and you are going to find the cumulative frequencies. How you find them? You are going to add all the numbers until that column over here. Okay. So 5. Children with age 5. Okay. So all the children with age 1, 2, 3, 4, and 5 is cumulative frequency, and number of children with age 1, 2, 3, 4, 5 is, as you can see, 24. Now here, 6. This is all the children until this age. Children with age 1, 2, 3, 4, 5, and 6. Altogether, I have 26. Now, with this grouping, let us see how we find cumulative frequency with this grouping. I have 1, 2 here, I have 3, 4 here, and 5, 6 here, okay? 1, 2 is 8, 3, 4 is 12. How I know it? 3, 4 is, you can see here, is 12, okay? And 5, 6 is 6. This means that kids with the ages 5 and 6, there are 6 kids with the ages 5 and 6. Okay. Now here, cumulative frequency, this is 8. Now, if I add this 2, is 20, okay, until this age group. And in the cumulative frequency, I add all these ones until here is 26. Now, here, we are going to see a different concept, a different word, learn outlier. We are going to learn outliers now, okay? Now, so bar diagram, pie charts are used for categorical variables. Don't forget it. Now, let me show you outliers. For this, I am going to directly search from here instead of drawing you graphs. Outliers. Yes. Let's see the images here. Okay, now we have an image. Oops. These are outliers, okay? All the other points, okay, all the other points are close to each other, okay, except these 2 points. Let me show you another graph. Now here, in this graph, these are outliers, as you can see. So out of group, okay, here, we have many outliers, okay? So let me have this bigger here. You can see that, okay, most of the measurements are close to each other, okay, except this one here, this one, and this one. These are called outliers. And this is a scatter plot, okay? This is a scatter plot. We are going to see them also. Now here, this is an outlier, okay? Well, hey, what's it's doing here? There's a joke over here, okay? So everything is close to each other, all the measurements, and there is a someone over there. For example, you are at the ages of 20, 21, okay? If we have a man here at 80, okay, age 80, so we say, oh, what are you doing here? Okay, are you in the right place? Are you sure? Okay, maybe that he decided to study. That's an outlier. Okay, if he decided to study at the age of 18, then he's an outlier. Okay, because all of you are similar ages and he is at a different age than you. Okay, maybe it's possible that after 80 years old, he decided that he's keen on statistics and he wants to fulfill his dreams and study. Okay, so it's possible. So maybe that we have an outlier over there. Okay, let me show you different graphics here. This is an outlier. Oops. Okay, so this is an outlier. Everything is online, and this is an outlier. So these are outliers you can see here. So everything is close to each other, and these are says page not found, but we see it in small. Yes, these two are outliers here. Now here, this one is an outlier, okay? Everything is close again, this is outside. Or we can have in different, now here, you see this is a box plot, okay? This is a box plot, and this is an outlier. We have a measurement over here, oh. So there's a different case, okay? It's not normal, okay? For example, our course is in English. If we have here a student who doesn't understand English, then we say, oh, you are an outlier. So our course is in English, okay? So everyone knows English, and you are not, you cannot understand English, okay? Okay, so these are outliers, different. I think that this concept is clear. So we can have some outliers. What we do when we have outliers? If we are delivering a reserve study, we take that outlier out of our study. If we have 100 students, okay, with ages 20 and 21, and one student at age 80, he's an outlier, okay? His feelings, his success, or his problems is different than all the other students with younger ages, okay? So we take him out of the study for not having wrong results, okay? Therefore, knowing outliers are important. Yes. So for categorical variables, we use bar diagram, and pie charts is also possible. Histogram, stem, leaf, box plot are used for numerical variables. Okay. Yes, here. For example, this is bar diagram. This is important because you had some mistake on this point. List the categories and represent the percent or count of individuals who fall in each category. Now here, number of subjects and treatment group. Okay, this is one group. Okay, this is first group, this is second group, this is third group. We represent it in bar chart. What this means, what this bar chart means? This bar chart means that this is group 1 and has 15 students. You see that 15, okay? Number of subjects, sorry, this is subjects. It doesn't need to be always students. This stands for, this y-axis stands for number of subjects. So this means that group 1, treatment group, has 15 subjects, and this group 2 has 25 subjects, as you can see, and this group 3 has 20 subjects, okay? So what are these? These here are frequencies, okay? So bar charts are good for representing frequencies as well as categorical variables. Now here, this is out of 60, okay? If we calculate out of the total of these frequencies, then this is called proportion, okay? Not frequency. Until now, we have learned, not percent, of course, we have learned frequencies and percent, okay? Percent is what is the value out of 100, okay? Percent means out of 100. Now, proportion is the value out of 60, okay? Out of 60, it is 15. Out of 60, it is 25. Out of 60, it is 20, okay? So here, this means that we have this proportion here, okay? When we have the division, the number, the result is called proportion. This is 1 because this is 60 over 60 is 1. Now here, these are percent, okay? What this means? So we have such a calculation. We think that, okay, out of 60, it is 15. So what is out of 100? Let me write it here. Okay, so out of 60, it is 15. So we think what is the value out of 100? Okay, this is called percent. Okay, so so writing it as out of 60. Okay, writing it as out of 60. Okay, this is called proportion. How we express it? We express it as 15 over 60. Okay. And we find the result is proportion. And this is called percentage. We multiply 15 by 100 and divide by 60. Okay, not this one, this one. Yes. So we find the percentages, and always total percent is 100. So we find our results out of 100. Now, percentages are good for pie charts, okay? So we can have a pie chart and we can use this percent. But if we have bar chart, we use these frequencies. Now here, okay, what we do here, as I said, this is pie chart of subjects in treatment groups, okay? So pie chart is good for this percent, 25%, this part represents 25%, this part represents 42%, 4%, and this is 32%. Yes, another graph. Now, this is called histogram. Let us see the difference of histogram and bar chart, okay? Histogram has no spaces in between, okay? But look here, this bar chart has spaces, okay? Histogram does not any space. And here, let us read what it writes here. Overall pattern can be described by its shape, center, and spread. Okay, so we, after these histograms, we can say that distribution is right skewed, left skewed, or normal. Okay, this is, as you can see, is right skewed. But generally we have a line here, and this is called normality line. It's not shown in this graphic. Now here the center lies between 800 to 100, and we can see that they are all close. There isn't one outlier here, okay, at the beginning, or maybe one very far away. Okay, there are no outliers. So these are the descriptive statistics of this histogram. It says that mean is 90%, 41, standard error is 3.90, median is 84, mode is 84, and you see that all the other descriptives. This is called descriptive statistics. Now here, this is another graphical representation, and this is called box plot. Okay, it is box. We represent our distribution with a box. Okay, now here, this is higher, as you can see. Okay, this is smaller. Okay, this is not a normal distribution. In a normal distribution, box is divided into two. Okay. Yes, and now here, what was mean? Let us recall, we have studied mean before. It's just adding these numbers and dividing by 1, 2, 3. If we have 3 numbers, we divide by 3. If we have 5 numbers, we divide by 5. Okay, so we add these numbers and we divide by 3. Okay, that's mean. Now, median, you put them in order. Okay, and if it is even, now here I put them in order, you can see here. Okay, and so how you find median is that the number at in the middle, okay, for this is 6, but here in this example you put them order. Okay, now it's not in order here, we have to put them in order. Let's calculate this in a different place. Right. I'm going to take this part and calculate review median for you. Yeah. Okay. Now we put them in order, and the middle one is the median here. Let us put these numbers in order. We can say that 2, 3, I have 5, 6, 7, and 9, right? 2, 4, 6. Yes, I have 6 numbers. Now here, it's important that yes, I have 6 numbers here. It's important that I shade here this one, okay, and I take the okay, yes. Okay, right. Now I put them in order here, okay, and the two numbers in between, I take, I add them, I divide by 2, and that's median. Okay. We solved many questions about this. Mode was the highest frequency. Oh, wait, you cannot see, I think. Current slide. Yes, mode is the observed value with the highest frequency. Okay, so range. Let us see what is range. Range is the difference of the maximum number and the small minimum number. Okay, so in this sequence, what is the maximum number is 100. Okay, the minimum number is 2. Range is the difference of the maximum number and the minimum number. Yes, here variance. Let us see what is variance. Okay, variance. This is a little bit complicated, but we are going to see so many questions. So I hope that it will be also okay. So square of the variance equals to, first of all, we have to find this is mean. Okay, mean of this distribution, and then we subtract all the numbers in the sequence and take its square and divide by n minus 1. For example, here. Let me take it to the other place and solve some more questions here. Okay, so we are going to find variance of these numbers here, 5, 7, and 3, okay? So, what I have to do when I have a sequence of numbers and I want to find variance, I have to find first of all mean. How I find mean? I add all of them and divide by 3 because I have 3 numbers, okay? And I find that mean is 5. Okay, that's good. Now here, mean is 5, mean is 5, mean is 5. So I subtract 5 from all of these numbers here. I subtract 5 and take square of the result and divide by the number of elements is 3, 3 minus 1. That's variance. Let's solve some other questions here. 1, 3, 5. So these are the numbers. So how many numbers I have here? Oh, you cannot see. Okay. Okay, these are my numbers. Put it here. Okay. So I'm going to order these numbers first thing. I don't need to order them for mean, but that's a good habit of doing this when you have numbers. Okay, so 2, 3, 4, 5, and 6, 4, 5, 6, and 8. Okay, 2, 4, 6, 8. 2, 4, 6, 8. Okay, that's good. Oops. Okay, now here I have 8 numbers. Okay, so what is mean here? For finding mean, I have to add all these numbers and divide by 8. So let's add them. 2, 4, 7, 11, 16, 22, 30. Right. 30 divided by 8. Okay, so what it's not let me change the numbers so make it easy for the calculation. 1 minute. 32, if I make it 32, so this means that I have 1, 3 here. Let's have, sorry, I'm going to make the question for, I'm going to give it like that in the exam. So this is 32, okay, over 8 is 4, right? So this is mean, okay? I don't want you also to work with decimal numbers because you are not going to use calculator, okay? We could have solved that question like that, but I changed my question to make it easy, and this will be how you will find it in your exam. So, yes, what is variance? Variance, okay, is square of standard deviation. We can represent it like that, or we can say its variance equals variance. Okay, so yes, equals. Now I am going to subtract 4 from all these numbers, okay, and think the absolute value, okay, because I'm going to take it square. So 3 square, 4 minus 1 is 3 square, okay, that's 9, okay. Here 4 minus 2 is 2, 2 square is 4, okay. Excuse me, 1 and 1, okay, I have 2 1 here, that's good. Now I have wait. Now yes, this I have 2 1. Now here this is 0, okay, I have 1 0, and this is 1 again, right? Do you understand why it's 1? Any questions here? Okay, now here this is 4, and that's 4 square is 16. What I do, I subtract 4 minus 8 is minus 4 square is, no, 4 minus 8 is minus 4, minus 4 square is 16, okay? So we add all these numbers and we are going to divide by n minus 1. What is n minus 1? 4 minus 1, and that's 3, okay? Now here, I'm going to add these numbers. This is 10, 15 until here, okay? 15, that's 20, and this is 36, okay? 36 over 3, which is 12, okay? So I have here this one, okay, that's 12. So what? So this is variance, okay? And standard deviation, which is S, is equal to square root of variance, okay? So yes, do you have any question here? Do you understand what I am explaining? Any question? Okay, so what is this? You can see that this is 2 square root of 3. How? Because this is 4 multiplied by 3, and we can take 2 outside, and that's 2 squared 3. Okay, I can write it like that, 2 squared 3. Right? Okay. Good. Yes, that's how we find it. This one. Okay. So let's continue with our presentation. Okay, this is how we find standard deviation. Now quartiles. Let us talk about what are quartiles, okay? So we have, for example, 25th quartile, 5th quartile, okay? Here the data which is in this 25th quartile or 5th quartile or 75th quartile. Yes, here for example, we have numbers here, okay? So in this number, how many numbers I have? 15 numbers, okay? So the first quartile, for finding first quartile, I add 1, divide by 4, and 4 is in the first quartile. This is Q1, okay? Now, here, for the first quartile, it is m plus 1 over 4. Okay, second quartile is 50%, and here this is second quartile. How many numbers I have here? 15. So 1, 2, 3, 4, 5, 6, 7, 8 number is the second quartile, And here you can see that now this is fourth observation here, and if I count the reverse side, 1, 2, 3, fourth observation from right to left is the third quartile, okay, and the number is 61. Okay, these are quartiles. And we have another concept of interquartile range. This is a difference between third quartile and first quartile, and this is 61 minus 40, that's 21. Okay. Yes, we have deciles. If data is ordered and divided into 10 parts, then cut points are called deciles. Okay, if you divide in 10 by 10, then these are called deciles. What are percentages? If it is ordered and divided into 100 parts, then cut points are called percentiles. 25% is Q1, 15% is the median here, always, and 75 percentile is Q3. Yes, now coefficient of a variation is the standard deviation of data divided by its mean. Okay, now how we find standard deviation? It's a square root of variance. Okay, and here we can express it. This is mean. Okay, and this is coefficient of a variation definition here. Yes, we have box plots. We have 5 numbers summary. We can represent in quartiles. Here, this is box plots. Yes, we have, since given us, you don't need to know the formula here. Okay, this is a little bit complicated. I don't want you to remember the formula of skewness, but you have to know all the other formulas. Okay, you have to know variance formula, standard deviation formula. Okay, these formulas I don't want you to find to remember, to know by heart skewness formula. Just know the definition. So positive or right skewed, what it means, this means that longer right tail. Okay, if it is positive or right skewed, it is longer right tail. If it is negative or left skewed, it is longer left tail. We can also express it like this, and it is asymmetric. Okay, it's not symmetric. Yes. So quartiles don't include this also. Yes, this is a histogram. Okay, you can see histogram of age in months. This x-axis is age in month, and this is number of subjects that they are taking. Box plot, you can see that this is not a normal distribution. This is not symmetric. This means that if it is in the middle, you can say that it's symmetric. If it's not in the middle, you say that it's not symmetric. Yes, any questions until here? Sure? Okay.